Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question number 17 on our 2018 Pascal paper. Suppose that P and Q are two different prime numbers, and that n is p squared times q squared. The number of possible values of n, with n being less than 1,000, is... Okay. Well, if n is p squared times q squared, we're going to get... That's really just pq squared. So we're looking for squares less than 1,000. So pq squared needs to be less than 1,000. We could then say, well, pq just needs to be less than the square root of 1,000. We can grab our calculator if we need to, or we could say, well, that's going to be less than 32. Okay, but if you need to, you grab your calculator for something like that. But I know, for example, some of my squares, and I know that 31 is 961, and I know 32 is 1024. So square root of 1,000 is about 31-ish, a little more than 31, so less than 32 is good. Alright, now P and Q are different primes, so really, what numbers less than 32 can be written as a product of two primes? 1, nah, 2, 3, 4, 5, 6... 6 is 1, but I'm just going to list them all out and then attack them in order. There's not that many to write out. And then we'll have a full picture and we can take a look at each one and either cross them off the list or confirm them. Okay, so the first thing I'm going to do, get rid of 1. 1 is not a prime, 1 is not a product of primes, 1 is what's called the multiplicative identity, and it's not really anything, but it's definitely not a prime. I've gotten into fights over this. 2, 3, 5, 7, basically any prime will not work. Uh, 29, 31. Okay, now 4, well that's 2 times 2, and that's not quite going to work. Same with 9 and 25. 8 and 16, they're powers of primes, powers of a single prime, so that's not going to work. Now 6 works. 6 is 2 times 3, 10, 2 times 5. 12 has more than 2 prime factors. 14 works just fine. Same with 15, that's 3 times 5. 18's out, it's 2 times 9, which is 2 times 3 times 3. Similarly, 20 is out, 21 is fine, that's 3 times 7, 22 is fine. That's 2 times 11, so 2 squared times 11 squared would give me an n that is 484, which is less than 1,000. 24 is out, 26 is good, because that's 2 times 13. 27's a power of 3, so not enough other primes there. 28, that's 4 times 7, so that's not going to work. And 30 is 2 times 3 times 5. So if we count these up, 1, 2, 3, 4, 5, 6, 7, we get 7 as our answer. And where is that in terms of possibilities? It's there at the end. So we're going to bubble in E for question number 17. Up next, quite naturally, question number 18. I will see you there.